An exercise on node method. The circuit is given and voltage of 2 ohm resistor Vx is asked. Okay, how to find that voltage? Anytime I can apply the node method, and remember these steps. First step was select a ground. Let me select this point. Many times the negative side of voltage source is very proper for the ground. Second step, name nodes. Okay, give some names. If you know the value, write the value. If you don't know the value, write a name. What's the voltage? 0 volts. It's known. What's the voltage? I don't know. Let me give a name. E1. What's the voltage of this point? It's not obvious. I cannot see. Let me give a name. What's the voltage of this point? Again, it's not obvious. Give a name. There is a node here. Can you see the voltage? Yes. There is a voltage source. Negative side is 0. Positive side should be equal to that value. So this point is equal to 14 volts. Okay. Then the third step is write KCL equations on unknown nodes. Okay, not on all nodes, but only unknown nodes. So there is only one unknown node in this circuit. Sorry, there are 3 unknown nodes. The KCL equation on E1. But let me define some currents. Let me say this is Ix. This is Iy. This is Iz. Okay. What is the KCL equation? What's entering to node E1? 3 amps. That's it. It's equal to summation of exiting Ix. Oh, I have calculated Ix. Okay, it's not very difficult. Then, what's the KCL equation on E2? Entering currents Ix, exiting currents Iy and Iz. Okay. What's the KCL equation on E2, E3? Entering currents Iy plus 7. Summation is 0. So what's Iy? Minus 7 amps. The first step is, fourth step is, rewrite the KCLs using node voltages. Okay. Yes. Okay, from here, Iz, if you rewrite this equation, Iz is equal to Ix minus Iy. Ix is 3 minus Iy is 7, so it's 10 amps. Okay. Then the fourth step is write KCL equations using node voltages. Okay, rewrite these. E1. Let me copy the circuit first and then rewrite. Okay. Equation 1. 3 is equal to Ix. What's Ix? Positive side node voltage, E1, minus negative side node voltage, E2 divided by the resistance. Okay. The second equation, Ix, what's Ix? Ix is this, E1 minus E2 divided by 2 ohm is equal to Iy. What's Iy? Iy is E2 minus E3, positive side minus negative side, divided by 5 plus Iz, E2 minus 14 divided by 7. Iz is this. This point is E2, this point is 14 volts, there is a voltage source here, divided by 7. Okay? Look, the current is from positive to negative, always. Current is coming from E2 to 14 volts. The third equation, Iy is E2 minus E3 divided by 5 is equal to, plus 7 is equal to 0. Okay? So here, as you see, there are 3 equations and there are 3 unknowns, E1, E2, E3. So you can solve that set. Okay? It's not difficult. Yes. If you calculate, for example, there are 3 equations. If you use the back substitution technique, for example, if you extract E1 from here and put E1 here, then if you extract from E3 from here and put E3 from here, then you will calculate E2. After calculating E2, put here and calculate E1, and then after calculating E2, you can calculate E3 too. Or you can do something like that. You can say on E1 entering current is 3, exiting current is Ix, so Ix is 3 amps. On E3 you can say entering current is Iy, plus 7 is 0, so Iy is minus 7. And on E2, Ix, what's Ix? Let me write. Ix is equal to Iy plus Iz. And you know Ix and Iy. Ix is 3 is equal to Iy is minus 7 plus Iz. So what's Iz? Iz is 10. So from here, let's write Iz. Iz is positive side node voltage minus negative side node voltage divided by resistance. Iz is positive side E2 minus negative side 14 divided by 7. What's that? 10. Okay? You will say that's E2 minus 14 divided by 7. So from here, what's E2? E2 is 70 plus 14, which is 84 volts. Okay, so E2 is easily calculated from here. Okay, after calculating E2, what's E3? There is a voltage drop, isn't it? What's the value of that voltage drop? Here, this point is 84 volts. Minus, there is a voltage drop. Voltage drop is current times resistance. Current is -7. Resistance is 5. Okay? E3 is equal to this voltage minus that voltage. So what's equal to? Okay, E3. Right. Or you can say IY is equal to positive side minus negative side divided by resistance. Okay? From here, you can reach that equation. Okay? So, similarly, you can find E1 like that. If you say how to find E1, you will say E1 minus E2. You know E2. Okay? Divided by the resistance is equal to IX. Okay? And you know this is 84. You know this. So you can easily find E1. E1 will be 2 times 3 plus 84. Okay? Which is equal to 690 volts. So remember the question, Vx, it was the voltage of 2 ohm. Okay, Vx is a voltage of a component, is the voltage of a component, which is equal to positive side node voltage minus negative side node voltage. Vx is equal to positive side minus negative side. What's the positive side? E1. What's the negative side? E2. E1 minus E2. What are they? E1 90. E2 84, which is equal to 6 volts. Okay.